We're going to begin our talk today about linear functions and slopes. The basic concept of slope is something you've probably worked with before. Slope is basically a rate of change. It's your change in y over your change in x, or your rise over your run. And we define the slope of a line between two distinct points. And we say two distinct points. We use x1, y1, the little subscripts 1s, and these little subscripts 2 signify that they're two distinct points. So our slope, we call that our m. This is y2 minus y1 over x2 minus x1. So with basic calculations, which is something you're going to need to do, let's find the slope of a line between the points 2, 3 and negative 1, 6. We're going to take our equation. Notice I have a lot of things written in this top one. Well, we basically need the slope, or m, in the actual equation. So m equals y2 minus y1 over x2 minus x1. Some of you may ask, does it matter which one's the first point, which one's the second point? No, it doesn't. Just got to keep them consistent, okay? So we'll call this second point our y1 and the second point our x2 y2 and the first point our x1 y1. So y2 minus y1 is 6 minus 3. x2 minus x1 is negative 1 minus 2. When we simplify it, we get 3 over negative 3, which tells us our slope is negative 1. Very simple calculations. Again, keeping them straight is really about the only challenge, and I think you guys can manage that. Now, how does slopes actually work? Well, slopes basically tell you what direction the line is going in, okay? I have a simple xy coordinate here. I got 4 different lines on there. The red line, this represents a positive slope. This slope is increasing from left to right, so we automatically know that slope is positive. The purple line decreases left to right, hence that slope is negative. Now, the blue line is a horizontal line, okay? That slope is 0 because there is no rise. So if I have rise over run, 0 divided by any number is still 0. Now, the black line here is a vertical line, and the slope of that line is actually undefined because there is no run. So rise over run would be a number divided by 0, and we can't divide by 0. Just some basic concepts. Also realize the slope tells you the steepness of the line. The steeper the line, the greater the magnitude of the slope, which makes sense. Equations for lines. This is one of the main points of this section. These two sections. We actually wind up out of this section with 5 equations for lines, and we're going to talk about each one. The first equation was what's known as standard form. ax plus by is equal to c. This form, it's just one of those things that you need to know, that if you see something like this, you know it's a line. But what do a, b, and c represent? Well, basically they're integers. What does that mean? That means they're not decimals or fractions. But they have really no significance aside from the fact that they're integers. So that when I go to find equations for lines, I am not going to actually plug in to a, b, and c. The next two ones are the ones that you're going to plug into the most. That's your point-slope form and your slope-intercept form. Your point-slope form is y minus y1 equals m times x minus x1. And here, m has a specific representation. It is your slope, which should make sense because we define m to be your slope. And x1 and y1 is actually a specific point. Hence, if you know a point and a slope, you can plug into the point-slope form. Now, the next one's called your slope-intercept form, where y equals mx plus b. Again, m is your slope, and b is actually your y-intercept in the form 0, b. So, if you know the slope and a y-intercept, you can plug into this form. Now, what are the main differences between these two forms? Well, in each case, you need to know slope. In each case, you need to know point. However, in the slope-intercept form, you specifically need to know the y-intercept. And how do we know if something's the y-intercept? Well, by definition, a point is a y-intercept if its x value is 0. Now, the last two ones are ones that they're very simple, but they seem to catch students off guard sometime. A vertical line, by definition, is defined to be x equals c, where c is some constant. So, for example, if I have the equation x equals 5, that is a vertical line through the x value 5. And a horizontal line, y equals a constant. Another example of that would be like y equals -1, where it's a horizontal line through the y value of -1. Now these are all wonderful, but what do we actually do with them? Well, we're going to focus on these second two, the point slope and the slope intercept. And typically what we're doing is we're given situations where we want to find equations for lines. And you always need two things to get an equation for a line. You always need a point, and you always need a slope. So when it asks for us equations for lines, the first two things we have to check off is to see if we have a point and a slope. So let's look at some examples. Our first example says write an equation of a line with slope 4 passing through the point -5, 4. Well, do I ask myself, do I have a point? Yes, they gave me a point. And do I have a slope? They gave you the slope as well. Now, I'm going to use the point slope formula. Okay? Some people have been taught you use other ways. I prefer this method, but in all honesty, when everything is said and done, we should have wound up with the same answers. I like this method because its name is what it says it is, point slope. I'm given some arbitrary point and a slope, and I can plug in. So I plug in 4 for my m, 4 for my y1, and -5 for my x1. Notice this right hand side becomes 4 times the quantity x plus 5. Well, when x1 was -5, x minus -5 is simply a plus 5, so please realize that. I'm going to distribute here. Then I'm going to solve for y. Well, some of you may ask, why do I want to solve for y? Well, we solve for y, we put it in slope-intercept form, because this allows us to write it as a function. Having y equals something allows us to substitute that y equals down the road for maybe f of x equals. So we started out with a point and a slope, and we were able to plug in and actually get an equation for a line. Now, there is only one line that's going to pass through this point and have that slope, so everybody should be getting the same answer. Our second example says write an equation of a line which passes through the points -2, 6 and 3, 1. We ask ourselves, do we have a point? Yes. Do we have a slope? No, we don't have a slope. However, we have 2 points. And we do know an equation for slope if I'm given 2 points. It's m equals y2 minus y1 over x2 minus x1. We plug in our y values, we get 6 minus 1. In our numerator, if we plug in our x values, we get -2 minus 3. This reduces to 5 over -5, which is -1. Well, now I have a slope, and I have 2 points. Question is, does it matter which point I use? Answer is simple, no. If you plug in either point and that slope, you will reduce and get the same answer. Let's use the first point, -2, 6. I'm going to plug in again into my point slope form. Y minus y1 equals m times x minus x1. I'm going to get y minus 6 is -1 times x plus 2. And when I finally reduce, I'm going to get y equals -x plus 4. I'm going to give you 2 examples of the special forms we looked at. We're going to do the same thing again. We want to write an equation of a line passing through 2 given points, -5, 6 and 3, 6. Well, again, I have a point, but in fact I have 2 points, but I don't have a slope. So I'm going to use my slope formula, y2 minus y1 over x2 minus x1, and figure out the actual slope. Well, when I do this, I wind up solving this and getting my numerator is 0, and my denominator is -8, and that reduces to 0. If you remember, okay, a slope with a line with a slope of 0 is a horizontal line. And by definition, a horizontal line has a formula, y equals a constant. Well, what's that constant? Look at our 2 points, -5, 6, 3, 6. Their y values are the same. So therefore, my formula for that line is simply y equals 6. Now, did you need to do all this work? Well, if you didn't catch it right away, but if you noticed it right away, your y values are the same, so you could automatically have jumped in and said, that's a horizontal line, and the equation is y equals 6. Now, similarly, we're going to look at our second example. It says write an equation of a line which passes through the points -2, 6 and -2, 4. Again, we have 2 points and no slope. So if we jump right in and plug into our slope formula, we wind up with a numerator of 2 and a denominator of 0, so it's undefined. Now, please be careful. We're saying the slope is undefined. We're not saying the line is undefined. Because if I pick any 2 points and I can put a line through them. Our goal is to find the equation for that line. And once again, I know that if I have an undefined slope, then that means I have a vertical line. And vertical lines are defined to be x equals a constant. Once again, look at our x values, -2,6, -2,4. X equals -2 is our answer. That's an equation for a vertical line passing through -2. Now the last thing we want to talk about is parallel versus perpendicular lines. Now, when I'm comparing parallel lines, what I'm really looking for are lines that have the same slope. These are very easy to work with, very simple concept. However, when dealing with perpendicular lines, those are lines that have slopes that are negative reciprocals. In other words, if my first line has a slope of 2, the negative reciprocal of that would be -1/2. I change the sign and I flip the number. So if my first line has a slope of -5/3, I change the sign and flip the number, I get a +3/5. Similarly, if my first line has a slope of 1/3, the second line would have a slope of -3. Every time to get the slope of the second line, the perpendicular line, I change the sign and flip the number. Let's look at a couple examples of parallel and perpendicular lines. And we're going to take the same approach we did before. It says write an equation of a line which passes through the point -2,6 and is parallel to 6x minus 4y equals 5. Again, I want the same thing. I want a point and a slope. I have a point, but I don't have a slope. But I do have an equation for a line. And if I take this equation for a line and I solve for y, this is in the form y equals mx plus b. In this case, it's y equals 3/2x minus 5/4. So this line has a slope of 3/2. What do I know about the two lines? Well, I know the two lines are parallel. Therefore, the slope I'm looking for is m equals 3/2. So now I have a slope and I have a point. And I can go back and do the same thing I've been doing before. Plug into my point slope formula. I get y minus 6 is 3/2 times x plus 2. I distribute my 3/2. I get y minus 6 is 3/2 x plus 3. And I bring everything to one side and solve for y. Y equals 3/2 x plus 9. Last example we want to look at is perpendicular lines. This says write an equation of a line which passes through the point 6,4 and is perpendicular to y equals 2x minus 5. Again, I want a point and a slope. I have the point 6,4. I don't have a slope, but I do have an equation for a line, and in fact this equation is already written in slope-intercept form. I know the slope of this line is 2. I know the slope of the line I'm looking for is perpendicular to that line. So if the slope of this line is 2, its negative reciprocal would be -1/2. So that is the slope that I'm looking for, is -1/2. Now I have a slope and a point. I'm going to once again plug into my point slope form. Y minus y1 equals m times x minus x1. I get y minus 4 equals -1/2 times x plus 6. And when I simplify this, I wind up with y equals -1/2 x plus 1. Good luck. Be careful working with all of these. There's a couple of other items in this section, but I think I covered some of the big ones. Let me know if you have any questions.